Have you ever wondered how your phone or computer can translate languages in real time? Or how virtual assistants understand your questions? A lot of that magic comes down to a revolutionary concept in artificial intelligence called the transformer model. Before the transformer, most AI models that dealt with sequences of data, like text or speech, relied on something called recurrence. Think of it like trying to read a book by only remembering the previous word you read. While that works for very short sentences, it becomes incredibly difficult to keep track of the context or meaning of longer texts. Imagine trying to follow a complex plot in a novel, only being able to remember the very last word. That's a bit like how older models struggled with long sequences. Welcome to our series on Attention is All You Need. Today we're diving into a core concept that makes this whole system tick, the encoder-decoder structure. So what's the big idea here? Think of it like translating a book from one language to another. You have one part that reads and understands the original text, and another part that writes the translated version. That's essentially what the encoder and decoder do in this architecture. The encoder's job is to take the input sequence, let's say a sentence in English, and turn it into a kind of abstract representation. It's like reading the sentence and getting the core meaning. This representation is then passed along to the decoder. Now, the decoder takes that abstract meaning from the encoder and starts generating the output sequence, one piece at a time. It's like writing the sentence in French. Welcome to our series on Attention is All You Need. Today we're diving into a core concept that makes this whole system tick, the abstract. So what's the big idea here? Well, before this paper, most of the super smart computer programs that translated languages or did other cool tech stuff used something called recurrent or convolutional neural networks. Think of them like really complex systems that process information step by step. Now, the geniuses behind this paper thought, what if we ditch all that complexity? They proposed a brand new way of building these systems, called the transformer. And get this, it gets rid of recurrence and convolutions entirely, relying only on attention mechanisms. Why is this so cool? Well, it turns out that these new transformer models are not only way better at tasks like translation, but they're also much faster to train and can handle information in a much more parallel way. This means they can learn from huge amounts of data much more efficiently. In fact, they achieved record-breaking results on some major translation tasks and even managed to generalize to other areas like understanding sentence structure. It's a pretty big deal because it shows that sometimes the simplest approach using a clever mechanism like attention can lead to the most powerful results. So there you have it, the core idea behind the transformer. It's all about focusing on attention to unlock new levels of performance and efficiency. Stick around for our next episode where we'll break down the architecture itself. Welcome to our series on Attention is All You Need. Today, we're diving into the nitty-gritty of how these amazing models learn, the training. And for the big models, it was a more substantial 3.5 days. That's a lot of computing power. When it comes to optimizing, they use something called the Atom Optimizer and a neat learning rate schedule that gradually increases, then decreases, which basically tells the model to be a little less certain about its predictions, which, surprisingly, actually helps it learn better. Welcome to our series on Attention is All You Need. Today we're diving into a core concept that makes this whole system tick, the abstract.